In today's class, we'll deal with some questions related to graphs in this chapter, motion. So, first off, example 1, figure below shows the displacement time graph, the motion of two boys A and B along the straight road in the same direction. So, as you can see, this is a displacement time graph. Time is given in hours, displacement in kilometers. Answer the following. When did B start after A? How far away was A from B when B started? Which of the two has greater velocity? When and where did B overtake A? Okay, as you can see, this line is for B and this line is for A. So A started initially, but B started after 2 hours after A started. And A had already reached 10 kilometers when B started. So when did B start after A? So B started after 2 hours from A. So first answer, B started 2 hours after A. Second question, how far away was A from B when B started? So B started at this point. So when B started, A had already reached 10 kilometers. See, when B started, A was here and this is 10 kilometers. Hence, for the second part, we'll write. So, A was 10 kilometers ahead from B when B started. All the solutions that we are getting is from the graph itself. Which of the two has the greater velocity? If you look in this graph, this is the angle that A makes and this is the angle that B makes. Clearly, the angle of A, the separation between these two lines and the separation between these two lines, the one with B is greater. As this separation is greater, therefore the velocity of B is greater. So for the third one, we'll write the slope of B is greater than the slope of A in displacement time graph. Slope represents velocity. Therefore, velocity of B is greater than velocity of A, since the slope of B is greater than the slope of A. Number 4th part, it's given when and where did B overtake A. So where they meet is the point where B is overtaking A. So A started over here, covered 20 kilometers before they meet, and B started here, covered 20 kilometers, this as well, when they met. So after 20 kilometers of journey, A and B meet each other and at that moment B overtakes A at 4 hour, because this overtaking takes place at 4 hour at 4 after from when A began its journey. So this is our solution for 4. When and where. Where is after 20 kilometers of journey, A and B meet each other, and at that moment B is overtaking A, because B is covering say 25 kilometers over here, but A is covering only around 22-23 kilometers over here. Hence B has overtaken A, and B overtakes A at 4 hours from when A began its journey. That is our solution for when. This is how we study displacement time graph. This is our first example. We'll proceed on to the next example. Please copy the question and the solutions as well by pausing the video. Second example. A train starts from rest and accelerates uniformly at 100 meter per minute square for 10 minutes. Find the velocity acquired by the train. It then maintains a constant velocity for 20 minutes. The brakes are then applied and the train is uniformly retarded. It comes to rest in 5 minutes. Draw a velocity time graph and use it to find the retardation in the last 5 minutes, the total distance traveled, and the average velocity of the train. So first of all, we'll draw the graph. Okay. Train starts from rest and accelerates uniformly for 10 meter per minute square for 10 minutes. So find the velocity acquired by the train. This is our first part. So in solution, initial velocity U is equals to 0 acceleration. Since acceleration is positive, we can see that it is increasing its velocity. So acceleration A is say 100 meters per minute square. Then time T is 10 minutes. Therefore, we know V is equals to U plus AT. We have done this before. So, which is equals to U is 0 plus A is 100 into T is 10. So, we get 100 into 10, that is 1000. Velocity will be in meter per minute. Then it maintains a constant velocity for 20 minutes. After reaching 100 meters per minute, it maintains its velocity for further 20 minutes. The brakes are then applied and the train is uniformly retarded. It comes to rest in 5 minutes. Let's draw the graph. We'll understand this via the graph. Let's say I made around 8 centimeter and I'll mark each centimeter as 1. And this final one will give an arrow. Here again, let's say we make 8 centimeter, about 8 centimeter. This is our arrow. 1 centimeter, 2, 3, 4, 5, 6, 7. This is our x-axis. This is our y-axis. In the x-axis, we are taking time in r. In the y-axis, we'll take velocity. Since we need to make velocity time graph, we are taking velocity in meters per minute. Time is in minutes, will not be taking in hours, we'll be taking it in minutes itself. Since time given to us is all the units are in minutes, we'll take the time in minutes itself. It will be more convenient. Now, what we will do is we have 10, then 20, means 30, 30 and 5, we have 35. 1, 2, 3, 4, 5, 6, 7. We have 7 parts. So 35 by 5, we can, 35 by 7, we can have each of 5 minutes. 15, 20, 25, 30, 35. So we have accommodated the last time interval as well. Now for velocity, as we can see, it is reaching a velocity of 1000 meters per minute. So instead of taking 10, 20, 30, if we take 10, 20, 30, reaching 1000 will become impossible. So what we'll do instead is we'll take 200, 400, 600, 800, 1000, 1200 and 1400. So this will be more convenient for us. Now it accelerates uniformly for this much for 10 minutes. So after 10 minutes the final velocity is 1000 meter per minute. So 10 minutes will make a line is reaching 1000. We'll make a dotted line over here and we'll join this as well with a dotted line. So it reaches here, starting from initial velocity 0, it reaches to 1000 in 10 minutes. So we have made the velocity time graph here. Next, it maintains a constant velocity. So constant velocity in velocity time graph is a straight line parallel to the x-axis for 20 minutes. Means from 10 to 20 minutes is till 30. We'll again make a line from 30, perpendicular line from x-axis, so that it meets this. We'll erase the extra portion. So first from 0 it reached till 1000, then from 1000 it maintains a constant velocity for 20 minutes. So it maintains this constant velocity for 20 minutes, and after 20 minutes what happens is the brakes are then applied and the train is uniformly retarded. It comes to rest in 5 minutes, then again velocity will go down to 0 in 5 minutes. So this is our velocity time graph. Now we need to find the retardation in the last 5 minutes. How do we find the retardation? So first part, acceleration in the last 5 minutes will be final velocity. Final velocity reached over here is 0 minus initial velocity is 1000 by the time taken is 5 minutes. So minus 1000 by 5 is 5 2s are 10, 200 meter per minute square. So this is our acceleration. So retardation in the last 5 minutes is negative of acceleration is retardation, so it becomes 200 meters per minute square. For the second part is the total distance traveled. How do we find the total distance traveled? Is we find the area of this curve. So say this is O. Let's name the other parts as well. Say this is A, this is B, this is C. So for the second part, the total distance traveled will be equals to area of the trapezium OABC. So that is equals to area of this trapezium will be sum of parallel sides. Sum of parallel sides is AB plus OC. AB plus OC by 2 into the distance between them. This distance between them is basically 1000. So AB is 30 minus 10 plus OC is our 35 by 2 into 1000. This is equals to 20 plus 35 is 55 by 2 into 1000. So 2, 500, 5, 5, 25, 2 in hand, 5, 5, 25, 26, 27, 0 is 0 meters. So the total distance traveled is 27,500 meters. And the third part, for the third part we need to find the average velocity. So average velocity is equals to displacement by total time taken. So displacement we found out to be 27500 and the total time is 35 minutes. So by 35. So 5 sevens are 5 5s are 25. We have 5 5s are 25 into 0 0. So does this cancel off with 7? No. So 7 7 49 49 60 we have 7 8s are 56. We have 40 left. 7 5s are 35. We have 5 left. 7 7s are 49. We have 1 left. 7 1s are 7. So this is our approximate value in meters per minute. 785.71 meters per minute. This is our average velocity of the vehicle. Okay, next example. A car starting from rest accelerates at a rate of 2 meters per second square for 5 seconds. For this journey, draw the velocity time graph, and in the second part we have draw the displacement time graph using the velocity time graph in part A. Okay. So first we need to find the final velocity just like we did in the first part. So solution starts from rest. So initial velocity u becomes 0. Acceleration A is 2 meter per second square and time t is 5 seconds. So V is equals to U plus 80, which is equals to U plus 2 into 5. So that becomes 10 meter per second. Okay, so this is an easy graph. What we have for velocity time graph is this. Similar marking like before, we will take 1 centimeter as 1 unit. X-axis, this is our y-axis, origin. This is reaching maximum of 10. So what we'll do is we'll take, okay, so this is our velocity time graph. This is, we are doing part A. So this is our velocity. Velocity is in meter per second, and here we're taking time in seconds. So time is 1, 2, 3, 4, 5 and 6. We're taking 2, 4, 6, 8, 10, 12, 14. So it's reaching 10 meter per second in 5 seconds with a constant acceleration. So velocity time graph, constant acceleration means a straight line. So in 5 seconds it is reaching 10. So we'll just make a dotted line over here. We'll make another dotted line here. We'll join the point of intersection to 0 because the velocity, initial velocity was 0. So this is our velocity time graph. For the second part, where we need to draw the displacement time graph, how can we find the displacement for each second is by finding the area between the velocity time graph. So for part P, so displacement in 1 second is this area, the area covered in 1 second, this area. Let's say we make lines that would be more convenient for you. So S1, the distance covered in 1 second is this triangle. So half into base is 1, base is 1 into height is 2. So this is equals to 1 meters. S2, the displacement in 2 seconds is half into base here is 2 into height is 4. So this is 4 meters. S3, half into base into height, this becomes 9 meters. S4 half into base into height, this becomes 16 meters. And S5 half into base into height, this becomes 25 meters. So we have distance traveled in 1 meters, 1 second, 2 second, 3 second, 4 second and 5 second. So we'll again draw the graph. Okay, we'll take this time in seconds. This is x-axis, this is y-axis. We are drawing the displacement time graph. So we'll take displacement in the y-axis. In meters. So since maximum we have 25 over here and we have 1, 2, 3, 4, 5, 6, 7. So what we'll do is we'll take 5 meters each. 5, 10, 15, 20, 25, 30, 35. This will be quite convenient for us to draw. So in 1 second it covered 1 meters, then 4 meters. So 1 second it was 1 meters. So time 1, 2, 3, 4, 5, 6. So in 1 second it was just 1 meters. We'll just plot them first. In the second it was 4 meters. So this will be somewhere about here. Third second we have 9 meters. In the fourth we have 16 meters. So we have somewhere over here. And in the fifth we have 25, that is over here. This is 1, 4, 9, 16, and this is our 25. So we'll join them free-handed. You can use a scale as well, but I personally prefer free-handed. So this becomes our velocity time graph. Sorry, displacement time graph from velocity time graph. Okay. Next example, we have a stone is vertically upwards with an initial velocity of 40 meter per second. Take g as 10 meter per second square. Draw the velocity time graph of the motion of the stone till it come back to the ground. Okay. So whenever you throw a ball upwards, say you throw a ball upwards, so what happens is there is an initial velocity. It will reach to a maximum height. It goes up, reaches to a maximum height. then there its velocity is 0, it stops over there. Then it starts coming downwards with an initial velocity of 0, comes down, reaches the ground with a maximum velocity. And there will be a certain velocity and the height will be same in both the cases. This is the ascent, this is the descent. So use the graph to find the maximum height reached by the stone. Okay, while going upwards, what will happen is it is going against gravity. So over here A will be equals to minus G, and while coming down it is coming along with gravity, so A will be equals to G. So first we need to draw the velocity time graph. Okay, so we have for ascent, means for going up, we have initial velocity as 40 meter per second. On reaching the top, its final velocity is 0 and acceleration is minus G because it is going against gravity. So let's find the time. So A is equals to V minus U by T. So this implies T is equals to V minus U by A. So we have from here, this is equals to final velocity is 0 minus U is of 40 by minus G. Let's take G as 10 meter per second square. So we are taking G as 10. So minus minus cancels off, 40 by 10 is 4. So we get time as 4 seconds. So time 1, initial time is 4 seconds. So if it takes 4 seconds to go up, it will also take 4 seconds to come down. So T2 will also be equals to 4 seconds. So total time of journey we get is 8 seconds time taken for the descent is equals to the time taken for ascent, which will be equals to 4 seconds. Therefore, total time of the journey is equals to 8 seconds. Okay, now let's make the graph. We have already studied that velocity can be positive as well as it can be negative. So here we'll also have negative velocity. Okay, so time is 1, 2, 3, 4, 5, 6, 7, 8. Why are we having negative velocity is because if you see, it was thrown vertically upwards. It reached a maximum height, then it started coming downwards. So our direction is upwards, but it starts coming downwards. That is why this opposite direction we take the velocity to be negative. So it started with a maximum velocity of 40, So we'll take 10, 20, 30, 40, here minus 10, minus 20, minus 30, minus 40. Acceleration is constant. This is our velocity in meter per second, and this is our time in seconds. So it started from 40, comes to 0 in 4 seconds. So we have this straight line. So at the end, at the 8th second, we can see that it reaches a velocity of minus 40. So with the same velocity as it was thrown upwards, while it is coming downwards, while reaching the ground, it will acquire 40 meter per second of velocity. Okay, use the graph to find the maximum height reached by the stone. So this area over here, when you find this area, we'll calculate the total displacement of the body while going upwards, because while reaching velocity 0, it is going completely upwards. So let's mark this as A, B. So first part, maximum height reached is equals to the displacement from initial position to maximum height, that will be the area of triangle AOB. Here we have a triangle, so that is equals to half into base into height is 40. Base is 4, height is 40. So this is equals to 80 meters. So the maximum height reached is of 80 meters. Second part, what is the net displacement and the total distance covered by the stone? For the second part, net displacement is equals to 0, because while it went upwards, it went up for 80 meters and it came down 80 meters. So from where it began, it reached back to its initial position. Hence, the net displacement will become 0. And the total distance covered is equals to 80 meters plus 80 meters, because it went up 80 meters and came down 80 meters. So the net distance covered will become 160 meters. So these are some examples for questions relating graphs in the chapter motion. In the next class, we'll learn about 3 equations of motions and also some problems relating them.